The wave equation. The wave speed is the speed at which energy is transferred, or the wave moves, through the medium. The wave speed for sound in air is about 340 meters per second, while for light in vehicle it's almost 300 million meters per second. An important equation connecting the speed of a wave with its frequency and wavelength can be determined as follows. We know that speed is distance over time taken. We can find the speed of the wave using the fact of one whole wavelength is the distance between two crests, and a wave will travel a distance of one whole wavelength in a time equal to one period. Wave speed is wavelength over period. The frequency of a wave is the reciprocal of the period, so the frequency is 1 over period. We can rewrite the equation as wave speed is frequency times wavelength. Clearly, for a given speed of wave, the greater the wavelength, the smaller the frequency, and vice versa. Now let's see how it works. Example. A source takes 0.1 second to produce one wave. Calculate the frequency of the waves. Period is the time taken to produce one wave, so period is 0.1 second. The frequency of a wave is the reciprocal of the period, so the frequency is 1 over 0.1. The frequency is 10 Hertz. It means that the source produces 10 waves each second. Example. The figure below represents the wave motion on a long rope and 3 crests pass a certain point every second. Calculate the wave speed. You see that we have 6 wavelengths in 3 meters. Three meters is 6 wavelengths, so one wavelength is 0.5 meter. 3 crests pass a certain point every second, so the frequency is 3 Hertz. Now take the wave equation and substitute the values. Another example. A longitudinal wave is represented in the figure below. It takes 2 seconds from point A to point B. Calculate the wavelength, the frequency, the wave speed. When a longitudinal wave propagates, it produces areas of compressions and areas of rarefactions. The number of compressions produced per second is the frequency of the wave and equals the frequency of the vibrating source. The distance between successive compressions is the wavelength. 3 wavelength is 60 centimeters. 1 wavelength is 20 centimeters or 0.2 meter. The source produces 3 waves in 2 seconds. So the period is 2 over 3 seconds. The frequency of a wave is the reciprocal of the period, so the frequency is 3 over 2 Hertz. Now take the wave equation and substitute the values. Now it is your turn.